Let's go to page 372, and this is lesson 8-5, and the objective of this lesson is to use the remainder and factor theorems to find factors of the polynomials and to solve polynomial equations. Okay, so let's say if you start with a function p of x equal to 2x3 minus 7x squared plus 5x minus 1. And let's say if you want to evaluate the function when x equal to 3. Okay? So normally you would just substitute in here. So p of 3, that means when x equal to 3, this will equal to 2 times 3 to the 3 power minus 7 times 3 squared plus 5 times 3 minus 1. So p of 3, so you go and work it out. So 3 cubed is 27 times 2 will give you 54. Okay, minus 3 squared is 9 times 7 is 63, and 5 times 3 is 15 minus 1. Okay, and then again you can use your calculator to work it out. So this will give you 5. Okay, and so that's your answer. Okay, so this is how you do it normally. But the synthetic division is a very powerful technique. You can use for many things. So actually, you can use the synthetic division to evaluate. So let's say if you have this and you want to evaluate, so you go 2, right? Negative 7, 5, negative 1. So if you want to evaluate when x equal to 3, since these all have equal, so don't take opposite. So just put over here. So again, you drop the number, you multiply, you add, multiply, you add, multiply, you add. See that? So your remainder equal to 5. And so you see the same thing. So that's why this is called the remainder theorem. So the remainder theorem says that when you use synthetic division, the remainder you get is same as if you were to evaluate. So evaluation and the remainder are the same. That's why it's called the remainder theorem. Okay? So that way you can use this technique instead of this. Because with this, you probably need to use calculator. This one is much quicker, and most of the time you don't need a calculator. Okay, okay, so let's go to example 1. Okay, so again, you want to evaluate p of 4. So you have p of x is equal to x to the 4 minus 14x squared plus 5x minus 3. And you're looking for p of negative 4. Okay? Okay, so again, if you do it a normal way, okay, so make sure you know how to use synthetic division because on problem it asks you to do that. Okay? So again, if you do it a normal way, okay, the long way, then you have to do the negative 4 to the 4 power minus 14 times negative 4 to the square plus 5 times negative 4 minus 3. Okay, so again, so don't do this. This is what you do normally if you don't know how to do the synthetic division. Okay, but I'm going to do it the way that you don't want to do. Okay, because it's messy and it's going to take a long time. Okay, so negative 4 to the 4 power, it will become 256. And again, you work it out. You should calculate negative 4 squared is 16 times negative 14. Will become negative 224. Again, numbers keep kind of big, so minus 20 minus 3. So p of negative 4 equal to 9. Okay? But again, you see it's kind of long. So you don't want to do this. Okay? So what you want to do is you want to use a synthetic division. So you're going to get 1, 0. That's not x3 power, so you have to have a 0. And negative 14, 5, negative 3. Okay? And you evaluate to a negative 4, right? So you drop the number, use your fingers. So multiply, you add, multiply, you add, multiply, you add, multiply, you add. And there you go, see? So answer is equal to 9. So this is much quicker than that. Okay, now let's go to the factor theorem. So the remainder theorem means a remainder and the evaluation are interchangeable. Okay? So now when you go to the next theorem, it says the factor theorem. So what the factor theorem says that if x minus r is a factor of a polynomial p of x. Okay, so if this is a factor of that means when you divide, so if this is a factor of that means you can divide exactly. That means the remainder will equal to 0. Okay, so once you know, so you can check if this is a factor of that or not by just dividing. And remember, the remainder and the evaluation are interchangeable. So before when we're gonna use this to evaluate, okay? So we're gonna use synthetic division to evaluate. Now we're gonna do the opposite. Now we're gonna use the evaluation to find out what this number is, and this will be your remainder. So if your evaluation is equal to 0, that means your remainder will equal to 0. That means if divide exactly, that means it's a factor. Okay. Now, so what's the advantage of each one? Okay. Well, the advantage of this is when you have a high power, when exponent is high, then you want to use factor theorem. When exponent is kind of low, you want to use the synthetic division. Okay. Okay, so let's go over example to see how this works. Okay, example 2, you want to determine whether x plus 1 here is a factor of p of x equal to x to the 12 minus 3x to the 8 minus 4x minus 2. So you want to find if this is a factor of that. That means you need to look for remainder. Okay, if the remainder is 0, then this is a factor, means you can divide exactly. Okay, but notice the exponent is really high. So if you were to use a synthetic division, it's going to be really, really long. Okay, because this is a 12 power, so you have to start with the 12 power, 11, 10, 9, 8, all the way to 1 power. So it's going to be super long. So that's the reason when you have a high exponent, you don't want to use synthetic division because it's going to be super long. Okay, so you don't want to do that. So what you want to do, you want to use evaluation. So from here, again, if you set x, if you set this equal to 0, you're going to get x equal to 1, right? Set it equal to 0, so x equal to 1. So x equal to 1 is your root. So now you're going to find out what would be the remainder is. Again, remainder and the evaluation are interchangeable. So now we're going to do the p of 1. Okay? So p of negative 1. So set this equal to 0, and you solve. So you're going to get x equal to negative 1. Okay, that's going to do it. That's going to do it, right? Okay. So you're going to evaluate p of negative 1. You want to put a root in here and to see what this will equal to. So you're going to get negative 1 to the 12th power minus 3 times negative 1 to the 8th power minus 4 times negative 1 minus 2. So p of negative 1, so negative to the even exponent is going to be positive. Negative 1 to the 8th power is going to give you positive 1 times negative 3 will give you minus 3. And this multiply, you get plus 4 minus 2. Okay. And p of negative 1, so when you add, this is going to equal to 0. Okay? So this is evaluation. So evaluation and remainder are interchangeable, right? So if evaluation equal to 0, that means remainder equal to 0. Right? Because they are interchangeable. Remember from before, right? Evaluation, right? From the very beginning, the evaluation and remainder are the same, right? So again, evaluation, right? From example 1, evaluation and the remainder are the same. They are the same. So now we're just going backwards, okay? So now we find these, then we can get that, right? Before is that we find this and we can get that, okay? So now. So again, evaluation is 0, that means remainder equal to 0. If the remainder equal to 0, means this divide this exactly. Therefore, this, yes, this is a factor of that. Okay, so yes, this is a factor of that. So this is called a factor theorem because you want to find out if this is a factor of that. Okay, now next, let's go to example 3. So it says find a polynomial equation with the integral coefficient that has 1, -2, and 3 over 2 as your roots. Okay, so what this point is that before, normally they would give you the equation and you solve for the roots or the answers. Right now they're going the reverse. Right now they give you the roots or the answers. You have to come up with the equation. Okay, so you just kind of work backward. Okay, you want to know where this came from. Okay, this came from x minus 1 equal to 0. This came from x plus 2 equal to 0. It's everything just opposite. And this answer came from x minus 3 over 2 equal to 0. That's where they came from. And where are these parts come from? Well, these are factors came from x minus 1, x plus 2, x minus 3 over 2 equal to 0. Okay? So from now on, you don't have to do this part anymore. You just go straight from here to here. Just know where this came from. This came from x minus 1 equal to 0. This came from x plus 2. Right? And again, when you set it equal to 0 and you solve, right? So we're just going backward. Again, this answer came from this, right? This one, this part of it, you set it equal to 0 and you solve. You get that, right? So from these, you can get your factors. Then after you get your factors, what you want to do is you want to multiply everything out, okay? And before I do anything, I don't like this fraction over here. So what I'm going to do, now remember this whole thing, all the factors together, this means one term. So this whole thing is one term, right? Because these are factors. So I'm going to multiply both sides by 2, okay? And again, this is one term, so you only multiply by one time. So you only multiply by 2 on both sides. Again, this whole thing is one term. So don't multiply by 2, by 2, by 2, okay? Because this whole thing is one term. Again, this is from your Algebra 1. Okay, so I'm going to leave this alone. But this part, when I multiply, I get 2x, and this will cancel out. Right? This times that give me this. This times that would be minus 3. 2 times 0 is still 0. Okay. Okay. The next part is I'm going to multiply this together because this one doesn't have a coefficient other than 1. Right? There's no number in front, so this is easier to multiply. So when you multiply, okay, so this will give you x squared. Now remember where the middle term came from. Middle term came from adding this. So negative 1 plus 2 will give you plus 1. So it'll be plus 1x. So again, you add to get the middle. You multiply to get the end. Okay, so that's kind of the reverse of the master product. Okay, so now I'm going to multiply using the distribution. Okay, so multiply, so I get 2x to the 3 minus 3x squared. Okay, so once I'm done with this one, I go to the next one. Again, use your fingers, so it helps you to keep track. So multiply, I get 2x squared. Multiply this 2, I get minus 3x. So once I'm done with this one, I'm going to go to this one. So again, multiply, I get minus 4x, and multiply, get plus 6. Okay? So now you're going to combine the like terms. Start with the highest degree, and you're going to combine this one and this one. So it'll be minus x squared. And this one and this one. So again, if they're same sign, you add the numbers together and you take the sign of the higher number. Okay, and so that's it. So again, normally you will have the equation, you will factor, and once you factor more, and you set each part equal to 0, okay, and then you solve. Okay, and right now just going backward. They give you the answers, you have to work your way to get your equation. Okay, now this is the whole equation. This kind of intermediate equation, these are called your depressed equations. So this part set this equal to 0, set this equal to 0. These are your depressed equations. Okay, now let's go to example 4. Okay, so you're going to use synthetic division to help you to solve equations. So you got x to the 3 plus x plus 10 equal to 0 until you have one of the root is equal to negative 2. Okay? Well, if you have one of the answer equal to negative 2, you can go and divide already to get rid of that and get your depressed equation. So the way to work is this. This came from x plus 2 equal to 0. Okay? So this is going to become x plus 2 and something. Okay? Well, how are you going to get this part? Well, this times this equal to that, so to get this you have to divide. So if you use this divide by this, you will get that. Okay? And so because division, you want to use synthetic division. So you got 1, 0, 1, 10. Right? There's no square term, so you have to have a 0. And this is to have equal, so you don't take the opposite of this. You take the opposite of that, which is this, right? So again, when you see the equal, you can just use it. Don't change the sign. Okay? So you drop, you multiply, you add, multiply, you add, multiply, you add. And again, you always have to equal to 0. Okay? Because why? Because this is a factor of that. Therefore, it must divide exactly. So if it does not divide exactly, you did something wrong. Right? So from here, so this divide by this will give you that. And this is x squared minus 2x plus 5 equal to 0. Okay, so this is going to be here. Okay, so again, from this you get this part. Once you get this part, you use this, divide by this, you get that. Right? And by instead of using the long division, you use synthetic division. Okay, so now, see, this is x to the 3 powers, so you're going to get 3 answers. Now, to get 3 answers, you already got 1, so you have to get 2 more answers, and you can get it from here. And this is not factorable, so you want to use quadratic formula. So you're going to get a equal to 1, b equal to negative 2, c equal to 5. So x equal to negative b plus or minus square root of b squared minus 4ac over 2a. So make sure you memorize your quadratic formula, okay, or you have someplace, somewhere handy you can look it up. Okay, so go and work it out. So it'd be 2 plus or minus square root of negative 2 squared is 4, minus negative 4 times 1 times 5 will give you minus 20, okay, over 2. So x equal to 2 plus or minus square root of negative 16, right? 4 minus 20 is negative 16. And keep going. So square root of 16 is 4. Square root of negative is I. Okay. And now you got everything is a multiple of 2. So what you want to do is you want to divide it by 2. Now there are 3 parts. So you have to divide this by 2, divide this by 2, divide this by 2. So you're going to get 1 plus or minus 2i. Okay. So the answer to this equation is the 3 answer would be here and this 2. Okay. So your answer would be negative 2, and you got 1 plus or minus 2i. So those are your 3 answers to that cubic equation.